Now that we've looked at how to calculate pH, and I'll put it up here as a reminder, that pH is equal to the negative log of our hydronium ion concentration of our solution. I'd like to talk about working backwards. What if we know pH and we want to know the actual concentration that we have of those H+ ions or hydronium ions? But we'll have to work backwards, and I think that warrants a little bit of attention because working with logarithms can be a little bit tricky at times. So we're basically going to reverse our pH calculation. And we're going to do that by rearranging our equation. So to be able to do that, let's come down here. So I've got my pH value. I'm going to space this out. So what I'm going to try to do is isolate my hydronium ion on one side, so that way I can easily calculate it. So to do that, the first thing I'm going to do is I'm going to imagine this in negative as -1 times. So I'm going to divide both sides by -1. And that is essentially going to mean that I have negative pH is equal to the log of H3O+. Now I'm going to try to eliminate this log function. And the opposite of a log algebraically is 10 to the exponent. So if I take this entire side of my equation and I make it the exponent to 10, then my log and my 10 will cancel out. Now, what I do to one side, I have to do to the other. So I'm going to take the entire left-hand side and raise it to the power of 10. Now, nothing here cancels out because there's no logarithm. So now I have 10 to the negative pH as an exponent will be equal to my concentration of H3O+. So now this is something I can plug into. At pH 7, 10 to the negative 7th, well, that equals 1 times 10 to the negative 7th. And that is what we said was the concentration of H3O+ when we just have water around and it's completely neutral. So plugging in our pH value as a negative exponent to the value 10 gives us our H3O+ concentration. Let's try another example or practice. If you'd like, pause the video and try to solve this question right here that I just wrote. And I'll go over the solution here in a second. All right, so I've been told that I have a pH of 7, and I'd really like to know what the concentration of my hydronium ion concentration is. So I'm going to use my equation that 10 to the negative pH is equal to the concentration of H3O+, or hydronium ion. So I'm going to really just plug in here. 10 to the negative 3.7 equals my concentration. I have a button on my calculator that says 10 carat. And when I hit, or 10x as well, if I hit this button, I can plug in exponent here, like negative 3.7. So that's what I'm going to do on my calculator. When I do that, I get a value that's 0.0001995, which is equal to H3O+. I can rewrite that in scientific notation too, if you like. 1, 2, 3, 4. So it's going to be to the negative 4. Okay, so I have a higher concentration of these hydronium ions than I did at pH 7. So at least that seems reasonable to me.